Hi everybody, welcome back. This is Unit 5, Lesson 3. And in this lesson today, we're going to talk about how to name non-binary compounds. So these compounds that we learn how to name will have more than 2 capital letters. They'll have at least 3. They might have more than 3, but they'll have at least 3 capital letters. Okay? And my little saying is when you see 3, go to table E. Because what you have inside of you, if you have 3 capital letters, is something called a polyatomic ion. And if we just take a look at table E, which I thought I already had up here, but I guess not. We're getting there. There we go. Here's table E. What a polyatomic ion is, what these things are groups of atoms bonded together with an overall charge that function as a unit. And since they're ions, they have an overall charge. Their charges don't equal 0. So some of you, when we started naming binary compounds, were asking me, well, what's nitrate then? Or what's sulfate? Where'd sulfate go? Or what's phosphate? Okay? Those are polyatomic ions. What makes phosphate is 1 atom of P and 4 atoms of oxygen stuck together. Okay? And instead of them being neutral, overall it has a charge of, not -2, but -3. Okay? This is the polyatomic ion phosphate. So the key when you see 3 capital letters is to come here to table E and find something on table E that is also in your compound. Okay? And you may have more than one thing from table E, but you want to find what's on table E that's also in your compound. Now you have a flow chart for non-binary compounds. I think it's 3 or 4 pages in your notes. 3 pages in your notes. It says naming inorganic, that means not carbon containing, non-binary compounds. And again, I'm off the screen. Okay? This is the flow chart you should be looking for. So first thing you want to do is make sure that there are more than 2 elements. If there are more than 2 elements, right, if you see 3, go to table E. That's the key. And try to identify what's in your compound that is also on table E. All right, so you're going to identify your polyatomics first. I think that's the easy way to do it. And then you can identify what's with your polyatomic, okay? So let's walk through this flowchart with a couple of examples. We'll kind of do it on a split screen here, and you can do them in your notes next to you. Okay. So let's say the first compound I have is this, okay? As you can see, there are 3 capital letters in this. So we are going to go to table E first and identify your polyatomic. So we will go here to table E and look for something in our compound that's also present in table E. Now I'll write it down. It was this. This was it. Here was our compound that we have to name. And what you may notice is that here in this compound is NO3, which is also on table E. Now you won't find the charge in the compound because compounds are neutral, but you will find the symbols and the subscript, okay? So this is your polyatomic, and whenever you have a polyatomic, no matter what's with it, you take the name right off the table. You don't do any switching, you don't add prefixes, nothing like that. You just take the name right off the table. So this is called nitrate. NO3 is nitrate. Nitrates are found in processed meats, like hot dogs or Slim Jim or ham, like lunch meat. They have a lot of nitrates in them. They're preservatives. And then Na is with it. So you want to identify what's with it. So this is your polyatomic, and we want to identify what's with it, which is a metal. Okay? When you have a metal with your polyatomic, just like when we had binary compounds, we want to go and look up our metal and see if our metal has only one possible oxidation state or more than one possible oxidation state. Because the rules that we learned when the metal has more than one charge still hold true here. Okay, you'll need parentheses after its name with the Roman numeral if it does. But ours does not. Okay, so we have a metal with only one oxidation state with a polyatomic. And so what we do when we name those, we'll call those type 4. Right here, right? We have a metal, yes, and our metal only has one oxidation state. We'll call those type 4. You name your metal, you name your polyatomic. That's why it's wise to identify where your polyatomic is, okay? And if you do have a metal with a polyatomic, the metal will always come first, okay, in the formula. Okay, here's another one for you. So there are 3 capital letters here, so when there are 3, go to table E, and we want to find the polyatomic. KMNO4, that's in our compound that's also present on this table. And there it is. MnO4 is a polyatomic, okay? So this is your polyatomic. K is to the left of the stairs, that's a metal. When there is a metal, you always got to look it up on the periodic table to see how many oxidation states it has. K only has 1. So as I'm naming this, I name my metal potassium. I name my polyatomic. Right off the table. Take the name right off the table. Again, no dropping the ending and adding IDE. Most polyatomics, not all, but most end in something other than IDE. So this one is a type 4 metal polyatomic. The metal only has 1 charge in the box. This is a type 4 metal polyatomic. The metal only has 1 charge in the box. What happens when the metal has more than 1 charge in the box? We'll call that type 5. Okay? The metal has more than 1 charge in the box. For example, let's say we had something like FeCO3. I see 3, that means I go to table E and first identify what the heck my polyatomic is. So let's erase these. Yeah, there we go. Okay. Okay. And if you notice, in this compound is CO3, which happens to be right there on table E. So this is our polyatomic, and what's with it is Fe, which is to the left of the stairs. That's a metal. So we have a metal with our polyatomic here, okay? The next step is to look up your metal and see if it only has one oxidation state or more than one. And Fe has more than one oxidation state. So what we do is we name our metal, just like before, and we put parentheses after its name. And then we name our polyatomic, just like with type 4. The only difference here is we don't know iron's charge. And so when you give me the name, you have to tell me what that charge is in Roman numerals inside the parentheses. So we give, just like when it was binary, we give iron the X. How many irons are there? If there's no subscript, it's a 1, okay? We look up the charge on the polyatomic, which is also given in table E. So we go here, and you see this -2, that's the charge, or 2-, that's the charge on carbonate when it's in compounds. So carbonate has a charge of -2. And then again, like before, we do bottom times top, this times this, 1x. Here is where you have to be careful. You do not take 3 times -2. There are not 3 carbonates. Okay? Carbonate is a CO3. That's what makes one carbonate, right? Is a CO3. So if your polyatomic is not in parentheses with a little number outside the parentheses, that means you only have one of it. What I recommend you do is put your polyatomic in parentheses if they're not there, and put a 1 outside of it. And then it's this times this, okay? 1x, 1 times -2, and that all has to equal 0. So x equals 2. That number goes in there in Roman numerals in parentheses. This is iron, Roman numeral 2, carbonate. This is a type 5. I'll give you one more of those and we'll call it a day, okay? Type 5, another type 5. Let's do, okay, let's do this one. You see 3 capital letters? Oh, yeah, we'll do this one. You see 3 capital letters, then you go to table E. If you see 3, go to table E. And we're going to identify what's in our compound that's also in table E. And what you may see is this guy, CN, which is known as cyanide. Yes, that's in rat poison and it will kill you. Okay? Cyanide's bad stuff. Tastes like cyanide. Is that the one? I think it tastes like almonds or smells like almonds or something. So you have to be careful with that. It smells good. But anyway, this is your polyatomic right here. What's with the polyatomic? Identify that. It's to the left of the stairs. It's a metal. When you have a metal, go and look it up and see if you need the parentheses or not. You do. Copper has more than one charge in the box. You need the parentheses. So we name our metal, copper. We put the parentheses after its name, and we name our polyatomic. Again, you take the name of that right off table E. This is copper cyanide, okay? We don't know if copper here is +1 or +2, so we put an X for copper. And we look up cyanide's charge from table E, just like we looked up the non-metal charge in the reference tables. And there's a negative next to cyanide, which means cyanide in compounds is going to be -1, okay? There's no subscript for copper, no little number down there, so it's a 1. And then we do bottom times top, 1x. There are 2 cyanides here. That's what this number means outside the parentheses. Bottom times top, -2, that has to equal 0. X equals 2. So that number goes in Roman numerals inside the parentheses. This is copper, Roman numeral 2, cyanide. Again, this is a type 5 compound. Okay, you have to use those rules to figure out how to name the type 5 compounds. Again, if there are no parentheses, like in this case, this is sulfate, okay, then you should add them and put a little 1 outside. But this time there were parentheses with the little number outside. You always use the number outside the parentheses of your polyatomic, and if there aren't parentheses around your polyatomic, you use a 1. Okay? All right, we're going to do some more practice with type 4 and 5, and probably actually finish up these notes tomorrow when you come in, so that we now know how to name all the compounds that there are. This is it. So we've done 4 and 5. We have to do 6 and 7. I know I make it sound easy, right? And then we're done. And that's why I said there's 7 different rules that you have to know when you name. But many of them kind of overlap, so it's not as bad as what it seems. Let's have you, since I sort of did this one for you, why don't you name this one for tomorrow, okay? So on your paper, you can go ahead and write down FeSO4 and give me its name for class tomorrow. Have a great night, everybody. We'll see you. Bye-bye.